Hello everyone, this is Alistair here, and today's problem of the day is titled Special Metrics, and it involves some form of dynamic programming approach to solve the problem. So let's have a look at the problem itself. So in this problem, you are given a matrix having n rows and m columns, and the special property of this matrix is that some of the cells are blocked, and the blocked cells are represented by the vector blocked underscore cells, which has few cell values, and the number of block cells is given by the integer k, and the size of the matrix itself is given by the integer n comma m. Now given this information and given the condition that you are allowed to traverse the cell only in horizontally right or vertically down direction, you have to find the number of ways that you can traverse the matrix from 1 comma 1 and reach the ending at n comma m. Now, in order to understand how we'll go over the problem, and let's consider this first example. So the first example has a matrix of size 3 comma 3, and it has a few block cells 1 comma 2 and 3 comma 2. So let's construct the matrix first. So we have a matrix of size 3 comma 3. So let's initialize the matrix with zeros first, and we are given that 1 comma 2 and 3 comma 2 are blocked, meaning if we start from 1 comma 1 indexing, then this particular cell and this particular cell is blocked. So let's replace them with something representable, that is -1. Now if you look closely, there's only one possible way to reach from 1 comma 1 to n comma m, that is 3 comma 3 in this case, and that possible way is to traverse down, then right, then again down. So that is the only possible scenario, because the cell immediately to the right of our starting cell is blocked, and it is represented by -1, and also this cell is blocked. So that limits our number of possible ways to reach this position y, and limits it to only one. Now how we'll go about the problem? So in order to go about the problem, what we'll do is we'll consider each and every cell of the given matrix and calculate the particular cell's possibility, like the possibility of reaching this particular cell, by consulting the cell right above it and immediately to its left. So if there is, say, let's say, two possible way of reaching this particular cell and three possible way of reaching this particular cell, given this cell is not -1, then the number of possible ways to reach the cell 2 comma 2 here in this case would be 2 plus 3, that is 5. So using this approach, we'll be able to calculate the number of possible ways of each cell, add them up, and the resultant value would get added up, and that final value would be represented by the last cell in our matrix. So let's consider some conditions that we need to consider. Like for example, uh, if we are considering these cells, that is the cells present at the edge of the matrix or towards the left, then there are no cells present to its immediate left or immediate above it for in this case. So for that, what we'll do is we'll simply initialize a matrix to have extra values. So let's say these are the extra values, and after doing this, what I'll do is I'll simply change this value to have -1. You'll come to know why I did this. After doing this, we'll simply follow the approach that we uh, had a look upon, and we'll consider this cell, consult the immediate cell to its left and immediate cell to its right, above to the one above it. So after consulting, I come to know that there's only one possible way to reach here, to reach 0 from above, and there's zero possible way to reach this particular cell from the left. So I'll add them up, and after adding up, I'll get the value 1 plus 0, which will give me 1. Now I'll consider this cell. Since this particular cell is blocked, I'll simply replace the -1 with 0. Now I'll consider this cell now. Now this cell, to reach this cell, there's 0 possible ways to reach this cell from above, and 0 possible ways again to reach the cell from the left. So I'll simply replace this 0 with, or I'll keep it as 0. And now we'll consider this particular cell, that is 1 comma 1, not 1 comma 1, 2 comma 1, and I'll consult the cell immediately to its left and the cell immediately above it. So there's one possible way to reach 0 over here from above and 0 from the left. So I'll add 1 plus 0, that will give me 1, and I'll do the same for every other cell. So for this particular cell, I'll have 1 plus 0, that would give me 1. For this particular cell, I'll have 1 plus 0 again, that would give me 1. And for this particular cell, I'll have 1 plus 0, that would give me 1 again. And for this particular cell, since it is minus 1, that is, it is blocked, I'll replace it with 0. And for this particular cell, I have one value above it and 0 immediately to its left. So I'll replace it with 1 plus 0, that would give me 1. And this would be our final result. Now let's jump right onto the code. So first we have to construct a matrix wherein we'll be storing our number of possible ways to reach each and every cell. So for that we'll create a matrix. Let's call it dp, and it will have the size n plus 1, since we are considering an extra row and column, extra row I must say, and a column as well. Yeah, so I'll construct that. After this is done, also in the note they have given that we have to return a total number of ways to reach n and m, and we have to calculate the modulo as well. So for that we'll create a variable mod and let it have the value 1e 9 plus 7, that is 10 raised to 9 plus 7. Now we'll loop over a given block cell vector and considering each and every value of the block cell and initialize them with -1 for our matrix dp. So we'll consider the block cells and we'll have not sp but dp, right? And we'll initialize them with -1 just like we discussed. Now what we'll do is we have to initialize this value with 1 in the beginning just to go over the approach that we discussed. So for that I'll simply place the 0 comma 1 value to have the value 1, and after that we'll loop over the matrix now within the loop. First we'll check if that particular cell value is -1 or not, and to do that we'll simply consider the cell I plus 1 and j plus 1. Now this is because this is the original matrix that we'll be dealing with and not this matrix, and since we are traversing from here we have to consider the cell, uh, consider this cell, and we can do that by simply incrementing I by 1 and j by 1. So that's why I'm considering I plus 1 and j plus 1 over here, and we'll check if this particular cell value is -1 or not, and if that is the case then we'll simply replace that I cell value with 0. And after doing this, if uh, if that is not the case, then what we'll do is we'll add up the values from the cell above it and the cell immediately to its left. And for that we'll consider this current cell again, and we'll consider the cell above it, that would be dp of I comma j plus 1, and add it with the cell immediately to its left, that would be dp of uh, I plus 1 and yeah I plus 1 and j. and also you have to consider the mod condition. So for that I'll take the modulo of this result, and yeah, this seems correct, and we'll simply return the last value of the cell, that is dp of n command. Also, to make it much more efficient, we could also consider the case wherein our if for example our initial cell, that is the 1 comma 1 cell, is uh, -1, then in that case there is no possible way to traverse the matrix. And also if our last cell is -1, then in that case also there's no possible way to reach the end. So if that is the case, we'll simply return 0. So let's check if our initial value, not 0 comma 0 but 1 comma 1, since we are considering extra row and column, if that is -1, or our last value, that is n comma m, if it's -1, yeah, if that is the case, then we'll simply return 0. Let's try and run the program. Okay, we got an error. Oh, my bad. Can't get enough of syntax errors. We got the right answer in the first case. Let's try and submit. Alright, so that was it for today's video. If you have any doubt or suggestions, you can uh, put them in the comment section, and thanks for watching.